Have you ever wanted to ride around campus, but you don't own a car, but you have a cooler, a few spare tires, and a drill? You can have a cooler scooter.
What's a cooler scooter?
A cooler scooter!
Cooler scooters are great. They're cheap, they're fuel efficient, and they're great for the environment because they're all electric. The only problem is they're not very reliable. The cooler scooter is propelled by a series of gears connected to a state-of-the-art engine, a drill. The drill is on a shaft that goes through two bearing pillows connected to a small sprocket that transfers the motion through a chain to a large sprocket. These are then connected to an axle which propels the wheels and propels the rest of the cart forward. Oh, didn't see you there. The other features of the cart include a state-of-the-art handlebars that are welded from an old scooter, as well as a brake, which is not a brake. It pulls a wire that will pull the trigger on the drill. The common failure mode for most cooler scooters is this sprocket right here. As you can see, when the trigger is pulled, this sprocket powers the gear. However, the shaft is bent because it's aluminum and this does not have infinite life. And you can see there's a little bit of wobble. When you engage the cart forward, you'll see the chain quickly falls off.
Well, why did it fail? Let me come tell ya.
Let's analyze the forces acting on each part. Here we have the shaft powered by the drill and supported by bearings. On the end, there's a sprocket that causes motion on the big gear that ultimately turns the axle connected to the wheel. As we have seen, there appears to be an initial force the cart is overcoming when pressing the gas. We have interpreted this as the torque needed to overcome static friction and ultimately the force that is causing our shaft to bend. Starting with the wheel, it supports a fraction of the weight of the cart and the person, which has an equal and opposite normal force. There is also a frictional force that opposes motion. The spinning wheel causes a torque on the axle that sits between the big gear and the wheel. The torque is equal to the wheel's frictional force, which as we saw before was the coefficient of static friction times the normal force, times r0, which is the radius of the wheel. The big gear causes motion on the sprocket, and so the torques can be drawn in opposite directions and the force is tangential to the small sprocket. The torque on the sprocket T2 equals the gear torque times the ratio of the number of teeth. This makes the tangential forces equal to the torque divided by the sprocket radius, labeled R1. Since our sprocket is at the end of the shaft, it is evident these tangential forces are the cause of the shaft being pushed forward and slightly down, making it bend. As defined before, this force is the torque on the sprocket divided by its radius, which we have now seen how the forces between each part contribute to the system's failures. Ultimately, we need new parts that can withstand these loads to fix our scooter.
Now that we know why the cart failed, we got a few new parts to fix it. We got a hardened steel shaft with a higher ultimate tensile strength, and we also got a bigger chain to help with easier alignment with our new gear.
Now that we have our new parts, let's take a look. We have our new standardized strong shaft right here, along with our two new sprockets and new gear. Now, let's take it for a test drive.